The overall goal of this protocol is to fabricate a soft unit to be integrated into a multi-module manipulator for use in minimally invasive surgery.
This method can help answer key questions in the field of soft robotics by showing how to optimize the fabrication procedure of a soft manipulator with high dexterity and stiffening capabilities. The main advantage of this technique is that it is very fast and low cost. In addition, the final product can be replicated to produce a multi-module architecture, improving the performance of the manipulator. Generally, individuals new to this method will struggle because silicon modules with complex shapes usually require a multi-phase fabrication procedure, whose optimization is often time-consuming. Visual demonstration of this method is critical, as the external sheet fabrication steps are difficult to learn, because they are based on a commercial braided sheath that is completely modified for the final purpose. Demonstrating the procedure will be Giada Gerboni, a PhD student, and Margherita Brancadoro, research assistant from my laboratory.
Add 12 grams of part A and 12 grams of part B in the same petri dish and mix them together to prepare the silicone. Then, place the mixed silicone in a degasser under 1 bar of vacuum pressure. Keep the material under vacuum until all of the bubbles have been removed from the silicone material. This typically takes about 10 minutes. Once the materials are completely free from the presence of bubbles, release the vacuum and remove the silicone, which is now ready to use.